Hey guys, it's great to be with you in here. My name is Jim. I'm the R&D manager for TOPWELL, and today we are going to talk about product development and product design from a customer standpoint. So what's the difference? Usually when we receive the customer requirements for a new product, it usually comes in his own words. I want to welcome our online friends in here. If you have any questions or requirements, just please post it in here or send us an email or post it on our online form on our website, and we will reply you instantly. So back to the product development. Usually we receive the requirements in the customer's words using his own expressions, which usually comes from his own field. So when the customer describes a product, that it has to look beautiful, it has to weigh light and not heavy, it has to be smooth. All these are just descriptive requirements. But we need to translate this into engineering specifications. So our engineering team can start processing these requirements and assessing them, and then once this is done, the customer requirements will become product specifications, which are translated into technical requirements or technical specs of the product. And then the development team will start working with these requirements, so the design would finally fulfill these requirements. And then when the product comes out, it will have all the required features that the customer has asked for, and then this can also be used to plan the quality control aspects and the checkpoints, the checklist that our QC personnel will be using on the production line in order to guarantee that the production is coming out according to what the customer has required. Now, this is a bit easy from outside, but when you think this deeply and when you consider all the requirements that come related to mechanical, electronics, firmware, product performance, user experience, all these has to work together. So by the end of the day, the end product, the final product, would come out exactly as the customer expected it to be, and it will perform exactly the same as how the customer wants it to be. This is a part science and a part an art. To give you an example, so let's say when the customer says, I need the product to be lightweight. So a lightweighted product means that it's not heavy. This is the standard or the initial impact of the requirement. But how do you translate this into numbers? Then we start asking the customer, we need to quantify this requirement to become a certain weight, and then So let's say he will say, okay, I don't need the product to exceed 100 grams totally. Okay, perfect. But we will also need a range, which means, let's say plus minus 5% is the acceptable range for the customer. So this means the customer accepts his product to weigh between 95 and 105 grams. That's a big range, okay, especially when you include the casing, when you include the packaging and cartons and the papers and documents and leaflets included inside the product. That was one example of a customer requirement which does not come in numbers, does not come specific enough in order to translate this requirement to become a specification. I would also want to welcome our online friends who are watching us. Please send us your questions, your requirements, and we will be back to you soon with our comments and notes. You can reach us at www.topwelldesign.com and on www.topwellmolding.com. And also, of course, you can just write down in here and our technical team will be back to you soon with an answer or a reply to your questions. So, if we move to the process, most of the time a customer will approach us with just an idea. He wants a product that solves a certain problem or that satisfies a certain need in his market or in his market niche, which is a very, very small segment through the whole market. And usually the customer will have an initial idea how to fill or how to fulfill this need, and by discussions and by dissecting his explanation or description to the problem, we can find together with the customer exactly if there is a possibility to fill the need that he is targeting with the idea that he is suggesting. If so, then we should have a possible approach in order to move to the next step, which is the proof of concept stage. If not, we would discuss this possibility or this situation with the customer and try to come up with alternative solutions, which every one of them can fulfill the need that the customer wants to cover in case that his original idea would not work. Once we pass this stage, then this is called the ideation stage, and within this stage we would work with the customer, inspecting and investigating various aspects of his suggested solution in order to reach a concept which should work. It didn't work yet. All this is mental discussions with customer. They are just most probably it's deeply technical discussions until we find a concept of operation that sounds to be successful in addressing the customer's needs. And once we pass this stage, then we can move to the next step. The next step is called proof of concept stage. In this proof of concept stage, it's time to just make a very simple and direct to the point mock-up or prototype or test circuit, and then we don't care about the size, we don't care about how the outlook, how does it look like. It's usually done on top of a bench or just by 3D printing some parts, prototyping some very quick PCBs. Most of the time we would also either use very quick MCUs, microcontrollers, just to test the idea. And usually if there is a certain actuator or there is a certain transducer in the solution, then we just focus on this. We need to validate if the solution that we and the customer are both suggesting, we need to validate if this solution will effectively fulfill the customer's need. And then by taking some measurements, by listing down some performance measures and indicators, this would give us an idea. Number one, if this solution looks promising or not. Number two, if it looks promising, is it promising enough? Is the solution bulletproof, or it still needs some improvements in order to rely on it and embed it inside a certain or a single product? Once this stage is passed, successfully passed, we usually end up with one or more viable solutions. So we either validate that the customer suggested idea or principle of operation is successful. That's one possibility. Or the modified one is successful and this modification does not hurt the product impact on the market. I mean, if you accept a working concept as a promising solution, it also has to fall within other constraints too. So it shouldn't be using some, let's say, hard to manufacture, hard to acquire, beyond the cost limits which the customer has already indicated in the very beginning. So this solution has to be fulfilling all these requirements. And then once this is done, then we move into the product idea design. This is where we start envisioning how to encapsulate this product or these features into a single product. And in this case also that we need to know if the competing products in the market, if they are already within the same category or not. And hey guys, I am welcoming our friends who are attending the show. Welcome to TOPWELL live show. If you have any questions, if you have any requirements, new projects you want to investigate or discuss, just please send us a message or write down in here or send us an email or visit our website, and our team will be shortly with you. Back to the point. We were discussing that the proof of concept has already been validated and the customer has approved that we do have a promising approach. Then once we move into the ideation phase, here is where we need to consider all the requirements and constraints that the product has to align to. If there are any special requirements in this market, if there are similar products already providing the same functionality in the market, we need to know what makes our idea either same or more competitive to the end customer. Is it price-wise? Is it features-wise? Is it size-wise? Or what? Every project will have its own circumstances, its own constraints. But by the end of the day, it's the customer's decision to go on with a certain approach or to prefer a certain approach, as long as it fulfills all the main constraints that he have reported to us or delivered to us in the beginning of the design phase. By the end of this phase, we will have some sketches, some quick drawings to indicate how big is the product, how does it look like, the expected materials, the expected color ranges, the expected surface finishes, any special requirements for the proposed product, how is it going, how is the user interface be distributed or arranged around the product. Most of our products these days will have a companion mobile phone app. So usually in this case, we would list down a long list with all the required features, with all the required user interface elements. And then here comes the compromise. Usually in every feature there is more than one way to realize them. Some of these features are realized via hardware, which means some components has to exist on the PCB in order to perform this functionality. Sometimes the same functionality can be done in firmware, which is the small program which sits inside the product on the CPU or the MCU chip, or this functionality can be done through the mobile phone app. And most of the time the functionality can be broken down into sub-functions where every one of them can be assigned to a certain aspect of the product. So if we are measuring, let's say, some sort of a signal, let's say a temperature, okay, if there is a certain temperature that has to show up on the user's mobile phone, and if this temperature is within a certain range between a minimum and maximum, okay, then there are no alerts. If it goes below or it goes above certain thresholds, then predefined actions has to be taken. So let's say a beeper will go on, an email will be sent out, an alert will be shown on the screen, and everything will be logged into a log file in the mobile phone or in the PC app if it's PC based, and so on. So to break this functionality, you would definitely need a temperature sensing element. If this is a dedicated temperature sensor, which means it's a temperature sensor chip to be installed on top of your PCB, okay, but remember that this temperature sensor is a separate component, which means it's an extra line, it's an extra cost in the BOM list of the product. Sometimes most of the MCUs will have internal temperature sensor. If this reading is good enough to give the customer an indication of the ambient temperature of the product, fine, we just save this sensor cost and chop it off the BOM list total cost, and since in all cases we are going to incorporate an MCU or a CPU in the product, then why not just use the internal temperature sensor and save some bucks off the BOM cost. I want also to welcome the newcomers, our friends who are watching us online. It's great to see you in here, guys. And as I've said before, please, if you have any questions, if you have any requirements, if you need to contact us, just please do it now. You can write down in here, or you can send us an email, or you can visit one of our websites, www.topwelldesign.com and www.topwellmolding.com. Thank you. Back to the product functionality stage. Sorry. Once this part has been concluded, then we will have separate lists for the product features. One of them is related to the hardware or to the PCB design. The other is related to the firmware or the software inside the CPU or MCU. The third one will be related to the mobile phone app or to the PC computer app if it exists in the requirements. So we have 3 separate lists. And of course, we do have the 3D mechanical design files, the 3D requirements for the casing. We didn't reach the mechanical design files yet. So all the requirements has been separated and assigned into separate lists, where each list goes to a certain team. So the mechanical guys would receive the casing, the enclosure, the material requirements. The hardware team will receive their PCB requirements. The firmware team will receive the same, and the software development, regardless if it's a mobile phone app or a PC app, they also will receive their list. Once this is all done, so everything is happening in parallel. So these are 4 lines going through together, of course, with full coordination between them. So the mechanical guys has to know how big does the PCB designer, how big of an area does he need, and the allocations of the user interface elements. Let it be an LCD, let it be a buzzer, a certain switches, if there is an antenna or not. The battery, how big is the battery? Is it rechargeable or dry replaceable one? If there is a charging socket, where should it be? How should it connect? If there is no recharging socket, are there BOGO pins? So there would be some sort of a magnetic cable to connect, or if the product will have a cradle where it will just sit in to charge. So this cradle also needs to be designed, and the charging mechanism where the BOGO pins touch, the male BOGO pins would touch the BOGO pads on the back of the device or on the side of the device, depends on each product. All this has to be taken into consideration, and there is no any way for these features to come out working correctly together without full coherence between the different teams, which means the project manager in this case is acting as a maestro for the band. He has to coordinate each and every single thing happening with every team. So by the end of the development of the initial development state, the 4 teams would converge together, where each one of them is providing his part. So the mechanical 3D files will be coming out, and the PCB 3D models and the PCB artwork are coming out, the firmware initial files are coming out, because usually the firmware is continued to be developed once the firmware guys start receiving the first board samples, I mean physical assembled PCBs. And of course the mobile phone apps or the PCB app guys will also have their initial wireframe semi-functional part or semi-functional models, where they need to try the interaction and communication between their part and the firmware and so on. So in this case, the customer will start seeing something physical functioning exactly as he has envisioned in the very beginning. In this case, the customer will start testing something in there in the field, where he can start getting initial feedbacks from his team, as if the product that they are, or if the prototype they are currently testing, does this really perform as expected or as imagined or as envisioned. Of course, there are a lot of details between these stages and a lot of information going back and forth between our teams and the customer, because by the end of the day, the customer is the interface who is receiving the product from our side and selling to his end customers from the other side. So he is in the middle, he is the interface, he is the joint between the end customer and the development team. The development team are guys who are doing something which the end customer expects to see when he starts using this, while the middle part in here is the product owner, and this is our customer. So by the end of the day, once our customer starts receiving final samples where they work as he expects, where they perform and look and feel the way he expects, then it's time to move to the next stage. So I would like to welcome our new friends who are joining our live show in here. It's great to see you. It's great to be with you in here. Please, if you have any questions, if you have any ideas that you need to discuss, just please drop us a line. You can write down in here. You can send us some request for quotation emails. You can contact us on our websites, www.topwelldesign.com, single word, and www.topwellmolding.com. Thank you.